Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets that we're going to be looking at are designed for conducting a project-based class, and this is essentially where students will be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. You're going to hear me drop his name a few times today. But anyway, just to get things going, we're going to start off where so many technology-focused presentations for education seem to start these days, and that's with talking about the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for improved STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, well, when you hear someone say this, what they're really talking about is the urgent need to prepare our students with the background that they're going to need to successfully compete in the job markets they're going to be graduating into. Now, in the employment market that once greeted, let's say, our parents or our grandparents, a good work ethic, a strong back, and being able to take direction on the fly might have been enough to land you a good paying job where many of the technical aspects could be learned along the way. But now, students must be prepared to enter a world that is increasingly focused on programming, on automation, things like IoT, and all sorts of rapid advances in technology. In short, students must be able to demonstrate technical literacy and aptitude if they really hope to compete and succeed. Now, this is, of course, why so much of the emphasis in education over the last 10 years or more has been on developing STEM skills. Every new advantage we enjoy, whether it's your smartphone, the tablets you use, whatever, all of these things were created because of individuals who helped to make those advances. Now, there are countries all around the globe, countries like China and India and what have you, that are making major strides in developing new technological advances, and they're busy preparing their own students to take their place in the future workforce. Here in the United States, we do also need to prepare the next generation of graduates with the skills, the mindset, and the type of habits that are going to enable them not only to secure jobs, but also to be part of that next wave of advancements that we depend upon to stay competitive on the world stage and, of course, to maintain the US's stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, we're going to back away from that, and we're going to move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science, all of which are, of course, extremely important subjects for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. But just how prized are they? Well, for example, the website careerexplorer.com lists an average salary for a mechatronics engineer in the United States of about $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, of course, they need to start developing the habits and the career focus that they're going to need for that as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether you're in a classroom or you're in a homeschool setting, doesn't really matter. In either case, you have to find ways of introducing this type of subject matter to students in a way that's going to keep them interested and involved in the learning process and not just memorizing obscure facts so that they can take a few tests and, purge that information out. No, what you really need to do is to really help students and to really encourage them to consider pursuing further education in subject areas like this. Educators need to be able to present the material in a way that makes it relevant, which of course means answering the eternal student question of why do we need to know this? And it also needs to be engaging in a way that really holds the student's attention and not just another textbook exercise or another video to watch. Something that has real world applications and where the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics Program sets. These two special sets, one of which is designed as an introduction to the world of mechatronics, and the second of which is intended to be essentially a standalone class dedicated to the subject, these were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, of course, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each of these sets. This curriculum is designed to align to the most widely accepted academic standards which are currently in place in the United States. The curriculum is also designed for offering a project-based learning program, and this means that solving the problems that are going to arise in each unit requires that the students have to be actively involved in the research. They have to be actively involved in the design phase, the trial and error, experimentation and activities, as well as the building of actual working prototypes that will help to provide the required answers. Now, our students are also not going to be asked to do this alone. They're going to be asked to work in small groups or teams of ideally 4 students each. And this is going to help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And when we, of course, mention soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and the big one, leadership. And finally, with the exception of some very affordable software programming software, actually, it's so affordable now. I'll give you a little spoiler. It's now free. So with the exception of some free software that we're going to show you where to download, each set includes all of the physical building materials that each group is going to need to enable it to address all of the design projects presented throughout the course of the curriculum. Now, the curriculum is designed to enable teachers of all backgrounds, and by this we mean even teachers from non-science or non-technology focused disciplines, because very often those are the folks that end up teaching a robotics class, a STEM class, what have you. It's designed to enable these teachers to have all the information they're going to need at hand to prepare them for conducting the activities and also to help increase their own comfort in presenting this type of material to the students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. In addition, there are also special tutorials that will familiarize students with the building system that they're going to use to address the projects being presented in each unit. Now, the units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging, real-world style scenario where students must work together in small teams, again, ideally 4 students per group, and they have to craft a solution to the problem they're presented with. The project units each contain embedded academics, and at the end of each of these units, the students are going to be required to make a formal presentation of whatever prototype they've created to address whatever the particular problem being put forth, the dilemma being put forth in the real world scenario. And they have to explain the reasoning behind why they constructed the prototype the way they did, how it works, etc. Now, there's a technical literacy task driven by each of these projects. Now, as students work to address each of these projects, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. And again, as required by each project, students are going to be asked to create original prototypes and, of course, any required programming-based solutions. And they also are going to be asked to maintain detailed documentation during the entire process. So that's a biggie. Now, as I mentioned a few times in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for us by a man named Tom White. And you see Tom right here on the slide. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for educational institutions as well as for industrial use. In fact, as an expert in hardware and software integration, Tom has been pivotal in introducing subject matter like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. And these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. When students ask, why do we need to know this? It's usually because the subject matter that they're being presented with may come across as being too abstract to ever really be useful in their lives. But with this project-based approach, students get to see firsthand why these things are necessary and where they're useful to know. The concept of working in these small groups to help solve these project problems, what have you, again, helps students to develop the high demand soft skills that employers also look for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and of course, problem solving. In this project-based format, all of the subject matter is integrated, meaning that the math is integrated with the reading and the writing and so on, which is really ideal for STEM education, where all these subject areas kind of blend together and tie in. Now, also because of the manner in which students must approach each of the projects being put forth in the curriculum, and this is, again, talk about the research, the testing, and the group give and take, just to give a couple examples. Because of this, it allows for a much deeper exploration of problems than traditional teaching methods might allow for. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, as you may very well in a classroom, if you have a classroom of 20 students, let's say, you probably have 5 groups or so working on things. When you have that going on, you should see variations in the types of prototypes and solutions being offered by each group. Now, this can be for several reasons. It could be because of differences in creativity between the groups, differences in the types of research and approaches taken by each group, or what have you. But in any case, what this allows students to do is students can see firsthand that a problem can have many different answers, and that often there isn't only one right answer, but there can be many answers that may serve something. And yes, maybe there's a better answer, but they get to see that firsthand. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each of these projects just in time. And students will be required to do extensive research as they complete these projects. Research, again, that is utilized in the design, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. Now, the team approach, as stated before, again, helps promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Again, just divide the number of students in your classroom by 4 to determine the number of sets that you're going to need for each class. And once again, everything you need to conduct the program, with the exception of the free programming software, which again, you can download, everything else is included inside of each box. Access to the free curriculum download is included again with the purchase of each set. So you get the software, you get the curriculum. That's a given. Just download those. Everything else is included. Now, all of the included building materials which students are going to use in the creation of each of these prototypes, these come from the unique Fisher Technic building system, and among the components included in each set are 2 robotic controllers, such as the one you see on your screen now, and 2 power supplies. Now, as I just threw something in there, let's tell you about Fisher Technic. So what is Fisher Technic? Well, Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets where they're designed primarily to stack, The Fisher Technic system was really the first one that was created with more of an engineering mindset. The core building block in the Fisher Technic system, as you see on the screen here, is unique in that it allows attachment from all 6 sides. And because of this, it allows for almost limitless technical design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method. And the system also includes a wide selection of very specific parts, meaning by that very specific types of gears, girders, sensors, rivets, and much more, which will allow technical builders to address equally specific design needs. Just to continue to give you a little bit more about the system, it was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations that were used in the construction and the automotive industries. Just to give you an example, Mr. Fischer at the time of his death in 2016 held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fischer is also known for being the inventor of synchronized flash photography. This was back in 1949. And he's also credited as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them at some point in our homes. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as many components used in automobile manufacturing, and they also provide consulting services related to high-end automated processes. Now, with that being said, let's begin to dive in and look at each of these 2 individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or if you're one of those people who likes acronyms, you could call it SIM. Now, this set is designed to help provide a well-rounded introduction to the core concepts behind mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. And the curriculum itself contains enough activity material to fill approximately 45 academic hours. With this in mind, we recommend this program set for insertion into regular related class activities. It can be used as a short class unto itself, could be used for after-school use, or of course for homeschool use. The curriculum created for the set is again standards focused, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle or high school classes, or again for addressing the same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fisher Technic building components, and this will of course include a wide array of gears, wheels, axles, blocks, sensors, and much more, as well as the 2 robotic controllers and 2 power supplies, which I mentioned before. Again, you will have to download the software and download the curriculum, and everything else is included in the box. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the various topics that arise during the course of the curriculum. Things like sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, working with software and the robotic controllers, working with sensors such as the digital switch and the digital photo transistor, learning about open loop and closed loop programming, as well as digital branching, working with analog sensors such as the photocell LDR, working with analog branching, more analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the actual curriculum, we're going to first take a look real quick at what's covered in the second set. Now, the second set is titled the Studica Teaching Applications of Mechatronics Program Sets, and using the same acronym format, we could call this one STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. Now, this set comes with access to a free downloadable 400+ page curriculum document, this one entitled Mechatronic Applications, and it's again by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill, and I do stress this, 180 academic hours. So essentially 4 times the amount of academic hours as were covered by the previously discussed set. Because of this, you can think of this as a more expansive version of the material touched upon in the previous set, and that it's really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day for 5 days a week, or the equivalent, depending upon how you choose to teach it. But essentially doing 50 minutes a day, 5 days a week, every day for a full academic year. Now, again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed, again, for use in middle school, high school, or for addressing similar grade levels in a homeschool environment. The materials in this set consist of a selection of over 1,200 Fisher Technic building components, again, all sorts of gears, blocks, axles, and much more, as well as the 2 robotic controllers and 2 power supplies. And again, you have to download the software. Now, there are twice as many project units included in the Studica teaching application of Mechatronics program set as with the previously discussed set, and this will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, as well as project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, there are also links that are provided to tutorial sections and activity materials for students to utilize. And these will include links on or sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and digital photo transistor, working with closed loop programming, learning about digital branching and logic gates, working with combinational logic, learning about edge triggered versus level triggered, learning about pneumatics, variables, positions, learning how to record positions, learning how to create a graphical user interface, learning about analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and working with data. Now that we've had a chance to look over each set and see how they differ and see the specific subject matter being addressed by each of the variations, let's now look at exactly how the curriculum itself is structured for these sets. Now, both versions of the curriculum do share the same essential format when it comes to the structure of how each unit is approached. And as already discussed, each version will include tutorial materials, activity materials, standards, and also your supplementary materials. Now, in each case, the curriculum is also designed to be somewhat turnkey. What I mean by that is each unit is designed to clearly spell out everything that's going to be addressed, and again, to provide tutorials and other information as various topics are introduced. Now, this was done specifically to enable teachers from all kinds of backgrounds, and it includes those teachers who come from, let's say, non-science and non-tech focused backgrounds, to be able to quickly become comfortable how to deliver this material by reviewing each section before it's presented in class. And again, the same links that the students can attach or check out, teachers are able to see what's being required, what's being asked of students for different sections. They'll, again, a nice review of this stuff will answer the questions for everyone. Each unit includes the following in the curriculum. So basically, as you enter each of the units, you're going to see an introduction. You're going to come across the purpose of the project. The concepts being addressed are going to be spelled out. There's going to be an outline of what's going to be covered. The standards for that unit will be spelled out. There will be assessment rubrics. The essential question is presented, which then leads to the student scenario, the real world style scenario I touched upon before, followed by a daily plan, and there are also vocabulary and resources included. So now let's take a look at each of those areas in a little more depth. Each unit will start with an introductory section and the purpose of the project. Now, just as you would likely gather from those names, these are the sections that provide a brief description of the topic that is going to be explored in the coming days and the activities. And it also is the section that will clearly try to spell out to the students why they're learning this material and why it's important for them to know. The next section will focus on the main concepts being addressed in the unit. And these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students need to take from this project that's going to be essential for them to understand and utilize not only today, but also that they're going to need to draw upon as they move forward in STEM fields of study. And if, of course, if they choose to pursue it, that they're going to need for STEM related careers. Following this section, we encounter the outline. Now, in the outline, we're going to drill down more specifically to exactly what's going to be addressed in the unit. Now, as the page that I'm sharing now on the screen is taken from the unit that addresses aspects of programming, you'll see that we touch upon areas such as the methods for writing programs, again, things like flow charts, word problems, and so on. Different program characteristics, open or closed loop, for example. Get into branching, things like digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards that are going to be addressed in that unit. As you will see, this will include the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, as well as general rubrics for literary tasks. Next, we come upon the essential question. This can be thought of as the big picture question that will be focused on in each of the smaller individual activities in the unit, and of course, all the aspects of the larger project which students are going to be asked to complete in this section. Next up is the student scenario. Again, this is where the specifics of the project to be addressed are finally spelled out. And it's presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of device or machine or mechanism. And as I mentioned before, students are going to be asked to work together in groups, small teams of 4 students, and solving the problem at hand is going to require each team of students to design a unique and original answer to the question, which once again is usually going to take the form of some sort of a working prototype, a mechanism, or what have you, along with whatever programming may be required if that's, if it's a unit that's going to require something to be, robotically controlled or what have you. So just to provide an example, if you look closely at the student scenario that I'm sharing on the screen in this slide, you will see that the project in this unit has each group of students taking on a role of a member of a design team employed by a firm that manufactures garage door openers. Now, in this particular scenario, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements for these doors are all spelled out, such as, in this case, the use of limit switches, having to meet certain safety codes that require a method for sensing if anything is in the way of a closing door, and also the need to incorporate an automatic light. So again, each team of students is being tasked with creating both a unique and original prototype, and again, in this case, it's garage door opening system, as well as creating whatever programming is needed to control that prototype. Now, as students move through the challenge being put forth in the scenario, each team is going to be required to document the entire process in both a design notebook and a digital engineering journal. And that means notating all of the research, all of the trial and error experiments, keeping copies of any design sketches and revisions that may be created along the way. And at the end of each of these project units, again, each team of students is going to be required to make a formal presentation in front of the class during which they're going to be asked to demonstrate their prototype and the programming in action, answer any questions about it, much as they would be required to do for an actual employer or client in the real world. So after that, we get into the outline, the daily plan. And this is the section that spells out clearly, both for students and teachers, what's going to be expected of the students and how the teacher is going to conduct the day's classroom activities, as well as what specific subject matter is going to be covered each day. Now you'll see that some days may involve, maybe they're going to concentrate on discussions. Other days may be more research oriented or deal with the building of small projects that will help provide the building blocks that students are going to draw on to complete the larger projects that they're being asked to complete. But in short, you can think of the daily plan as a roadmap designed to keep everyone on the same pathway. Now, you will see too that along the way, as different aspects are addressed in each day's activities, when things come up, such as what is required in a design notebook or how to use a control software, working with the controller, with flowcharts or whatever, that as each of these things come up, there are links to sections which will provide further instructions and information on each of these areas. So again, even if you didn't know what's required for a design notebook, you're going to be able to click on that link and it's going to spell out the parameters of what you need to do. Now, at the completion of each unit, after the last day of the daily plan, there is a section containing vocabulary. And these you can think of as essentially, of course, important words, but also terminology introduced during the project unit. And there's also usually a selection of useful resource materials. Now, these resources can be a variety of different things. It could be carefully vetted websites and video links. It might be PDF documents. It could be PowerPoints, what have you. It's going to really depend on the chapter at hand. Besides the project units, each of the curriculum documents also includes a special tutorial section that's designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this will include information on how the parts fit together, again, using that pin and groove assembly method I mentioned before, identifying the different types of parts, from the various types of girders and blocks, the different types of axles, gears, rivets, much more. And students are also going to be able to build a very basic sample model that will at least help them familiarize them with the way the system works before they're going to be asked to move on to these larger projects being put forth in each unit. And again, is learning about and maintaining proper documentation is one of the areas highly stressed in the course of this curriculum. There is also a section which details just what defines each type of documentation listed on the screen now and what is going to be required for each of these. And as the process of conducting these types of more open project-based class activities may be new to many teachers, there is also a section that discusses specifically project-based STEM education and its benefits. And that essentially completes our overview of these two sets. So now let's quickly review the contents and purpose of each set, but this time we'll get into the pricing. First off, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused, project-based introduction to the core concepts behind mechatronics. Again, this includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals by Tom White. And the curriculum, when used in conjunction with the building materials for this set, again, is designed to provide teachers with enough activity material to fill approximately 45 academic hours. Now, again, because of this time frame, this is designed for educators who wish to offer a shorter class on this material, who may want to incorporate it in a class that's, where this will just kind of fit in, use it for after school programs, or of course, for anybody who's dealing with homeschool use. The teaching materials designed for, again, use in middle schools and high schools, as well as by homeschooling parents seeking to address mechatronics at this grade level. And the physical materials include that selection of over 700 components taken from the Fisher Technic building system, as well as 2 robotic control units and 2 power supplies. Again, these are the materials that are going to be used to construct the various mechanical prototypes being addressed in each of the project units of the curriculum. And again, the software is not included, but it's downloadable for free. Again, each set is designed to be used by a team of 4 students, And the pricing on these sets starts at just $699 for a single set. Now, if you do need discount classroom pricing for groups of 20 students and up, that's available by quote upon request. So you can contact us. We'll be happy to get you a quote for that. Next is the Studica Teaching Application and Mechatronics Program set. This is the stamp set. Once again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, and it's all based around a highly detailed 400 plus page curriculum document entitled Mechatronic Applications, written again by Tom White. And again, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. And because of this, it's designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent. If you do it all on one day, that's up to you. But essentially that you have to be willing to set aside this amount of time for this class, 5 days a week, 50 minutes a day, for a full academic year. Set is again designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each set contains 1,200 components from the Fisher Technic building system, the whole array of parts that we've mentioned before, and again, the 2 robotic control units and the 2 power supplies. Software is free to download. And each set is designed for use again by teams of 4 students. Pricing for a single set on this one starts at just $799 per set. And again, if you need discount classroom pricing for 20 students or more, we will be happy to provide that to you, provide you a quote with that upon request. Again, the software I've talked about several times. Software in question is called Fisher Technic RoboPro software, and it's a graphic programming software. And what I mean by that is that it uses a flowchart style design using various icons which students arrange and link to create the programs being used for each of these models. Because of this, it's ideal for teaching the fundamentals of programming to users of all levels. Now, this used to be something that was sold. It was, as you see in the picture over here, it used to be available on disk. Now it's simply posted on the fishertechnic.de website. The manufacturer is out of Germany. So you can go to their website. They have a section with downloads on there, and specifically the RoboPro is available there. It can be downloaded right from the website. And again, this is for use with Windows 7, 8, or 10. It is unfortunately not workable with Chromebooks. So if that's concerned, please know that going in. So on that note, we have the question slide. So if anyone does have any questions, I would ask that you use either the webinar chat window or the question and answer window. Feel free to type anything in that you might have a question about. I will kind of talk for a second, and if I don't see any motion going on, I'm going to move to the next slide where I give a little bit of information. 1 and 2. Okay. So if you'd like to take the next step, if you'd like to request one of those quotes that I mentioned, if you would like to speak with your dedicated educational representative, in either case, you can call us. These pertain to the U.S. office, so call us in the U.S. It's our number at Studica is 888-561-7521. You can email us at infoinfo@studica.com. Any quote requests, any questions you have about either the program that I talked about today, or the Fisher Technic building system, or any of the other Fisher Technic solutions which are available. There are many subject-specific STEM-related sets that Fisher Technic offers on areas like renewable energy, mechanics, electronics, things of this nature. A full line of robotics sets that are very specialized, as well as a full line of industrial simulation and training models, which are usually used in higher ed and for industrial training purposes, where they're learning about PLCs and automation and control systems. But if you have any questions about any of that, you can email me directly. My email, as you see, is lance.zurek, lance.zurek @studica.com. So on that note, it's a lot of information. I thank you very much for taking the time to attend today. We do look forward to hearing from you. So again, please copy down that information. Feel free to reach out to us. We'd be happy to hear from you. So have a great day. Thank you very much for attending.